So here we're going to look at triangle, but specifically, we are looking actually at a scale factor in context of triangle, but it's a context of length and area. So Finn is making a pair of triangular tables, one bigger than the other. The bigger tabletop is an enlargement of the smaller tabletop. The scale factor of the enlargement is k. So when it comes to scale factor, so when you are seeing that expression or enlargement, you are thinking about the piece of knowledge that we need that has to do with our scale factor is that when we multiply length by the scale factor, we get enlarged length. So in this case, when we multiply the length of what? Small table, then we get the length of big table. Now, the second piece of knowledge has to do with area. And here again, if we take the area of small table triangle, we multiply by scale factor to the power of 2. Therefore, we get the enlarged area of the big table triangle. So let's see how this knowledge is applied here. The longest side of the bigger tabletop is 45. So one of the sides, so we are talking about what? Length, isn't it? Now, the bigger means what? The enlarged. The longest side of the smaller table, so that means that length that is not enlarged, is 36. Therefore, we have to show, so meaning calculate the factor k, the scale factor. And usually, yes, the scale factor is noted with the letter k. So that means, how did they got that? We are talking about the length. So we are taking the small length, 36. We will multiply by the scale factor, which is k, and that equals the enlarged length, in this case 45. Now we want the value of k, not k multiplied by 36, so to eliminate multiplication, we divide, and we divide both sides of the equation. Therefore, we have k equal 45 divided by 36, and when we put that in the calculator, indeed we get 1.25. So that's the scale factor, now we have it. Then the next part is saying the shortest side of the smaller tabletop. So we are still talking about length, isn't it? Not the area. Is 25. Work out the length of the shortest side of bigger tabletop. So we are using that first idea when we are taking the length that is not enlarged, in this case, the small table, so 25.5. We multiply that by the scale factor, which now we know is 1.25, and that equal what? The big table length. Well, that side. And again, when we put that in the calculator, we get 31.875. Now we have to give it to one decimal place, so 7 gets cut off, so 31.9, because 7 is 5 and greater, and that is in centimeters. Okay, and then the last part of this question, let's just get that our knowledge here with us. Okay, so the area of the bigger table, so now we are moving to the area. So the area of the bigger table, so we are talking about this area, is 724. Use k, which is 1.25, that's our scale factor, to find the area of the smaller tabletop. So this is the area that we are looking for. So let's create our equation. That means the area of that small table, so let's put AS, for example, multiply by the scale factor, which is 1.25, and that is taken to the power of 2, and that will give us the enlarged area of 724. Now we want that area, not area multiplied by a number, so again, to eliminate multiplication, we divide, and we divide both sides of the equation. So in this case, we're going to have that area of the small table equals 724 divided by 1.25 to the power of 2. And again, if we put that in the calculator, we get 463.36. And we are told terms and condition nearest centimeter, so we cut off 463 centimeters. Don't forget that that is centimeters squared. And this is the topic that very often comes up on your exam. So one difficulty here is that those formulas are not in your table, so you have to remember them. Length multiplied by the scale factor give you the enlarged length, and when it comes to the area, the only difference here is that we take scale factor to the power of 2.